In this video, we are going to talk about the velocity time graph. So we want just to understand how can you solve questions under velocity time graph. Okay, let's say we have been asked to say we need to find the acceleration from point A to B. Okay, so we know that acceleration is given by the v final minus v initial over time. Okay, so in a case where we have been asked to find the acceleration from point A to B, as we can see here, we are going to have 0. Okay, so meaning that our initial velocity is going to be 0. It started from 0 all the way to 5. That is the velocity. By the way, this is the y-axis, this is the x-axis. So in y-axis we have the velocity, and in x-axis we have the time. So we are trying to find the acceleration in the from point A to B. So what we are supposed to do here is we are going to have our final velocity as 5 minus the initial is 0 over we have the time. So the time we have got, if we can see here where there is 5, where there is B, it's going to be the time between 3, between 2 and 4, which is going to be 3 here. Here there is 3, here there is 1, here there is 5, here there is 7. So this one is going to give us what? It's going to give us 3, meaning that the time is 3. Okay, meaning that our acceleration in that case is going to be equal to if we do 5, we do 5 divided by 3, I'm getting 1.67. It's 1.666, but you can just round it off and say 1.67. Okay, that is meters per second squared. Okay, this is our acceleration from point A to B. Now, what would be the acceleration from point B to C? Now, as you can see, from point B to C, the velocity is not changing. So if the velocity is not changing, if the velocity is constant, in short, means that the acceleration is 0. Why are we saying that the velocity, when the velocity is constant, the acceleration is 0? Here's the reason. Let's say we want to find the acceleration. We know that acceleration is v final minus v initial over time. Okay, so the time we're talking about is the time between B and C. So we have the acceleration. The final velocity which we're going to have here is going to be our 6 here. So we're going to have 6. Sorry, I mean the velocity, that's not time. So the velocity is going to be 5. The final is going to be 5 minus, even the initial, the same line is 5. Okay, divided by time. Time is in between this part here and this part here. So it's going to be 6 minus 3 is going to give us 3. So we're going to have acceleration is equal to 0 over 3, which is going to give us 0. That's why we are saying that if the velocity is constant, definitely the acceleration is 0. So as long as you hear to say the velocity is constant, meaning the acceleration there is 0. Okay, now let's see, let's calculate now the velocity from point C to D. Sorry, the acceleration. So we're going to have acceleration is going to be equal to the same formula divided by time. So we have got the final velocity. In this case, we're going to have this line at D here. We have got 0 minus the initial velocity. We're going to have 5. Okay, everything divided by the time which we're talking about here is this 8 minus 6, which is going to be 2. So we're going to have our acceleration is going to be equal to negative 5 divided by 2. So I'm getting 2.5. So I'm getting negative 2.5 meters per second squared. So now that is deceleration actually. It is decelerating. It is coming to rest. That is the reason why the acceleration is negative. Okay, so this is how you can find acceleration on velocity time graph. But now, under velocity time graph, you might be asked to find the distance. Okay, sometimes they can ask you to find the distance in the first maybe in the first 3 seconds. Okay, so this is the 3 we're talking about. So we want to find the displacement in the first 3 seconds. Okay, or maybe from point A to B. That is in simple terms. From point A to B, how can we find the displacement? So now to find the displacement under velocity time graph is the same as finding the area under the curve. So the moment I find the area in this curve, that will be my displacement. Okay, so I'm going to say that the area is going to, that is a triangle, so it's going to be half BH. So I'm going to have half my B is going to be this line, which is going to be 3 times the height, which is going to be 5. Okay, meaning that I'm supposed to say 3 times 5, and then the answer I find 1 over 2 is the same as 0.5. So I'm going to say times 0.5. So I'm getting a 7.5 meters. So that is the displacement from A to B. Okay, but they can also ask us to say what is the displacement from B to C. Okay, so the displacement from B to C. Now let's first do this. From A all the way to B, the displacement we are saying is 7.5 meters. Now what of B all the way to C? Let's see. The shape which we have here is a rectangle. Okay, so what you're going to have is going to be, if you want to find the area, it's going to be L times B. Okay, we are going to have L times B. So our L length, you can think of this is your length, or you can think of that as your length. Okay, so we are going to say that the length which we have here is going to be, maybe you want to think of the height to be the length. That is the same thing. So we have the length as 5 times the breadth, as we can say, is 3, is 6 minus 3, which is going to give us 3. So I'm getting a 15. So that is 15 meters. That is the distance from B to C. Okay, that is 15 meters. Okay, now we need also to find the displacement or the distance from C to D, which is going to be the same. We are just supposed to find the area under this curve. So it's going to be the area going to be equal to half BH. To find the area, if you have been given a triangle, this is the formula: half BH, the breadth times the height. So what is the breadth which we have? We have got the breadth as 6 to 8. Now you say 8 minus 6, which is going to give us 2, times the height is 5. So I can cancel the 2 and I'm going to remain with 5 meters, meaning that if from C all the way to D, I'm getting 5 meters. Now, another question they can ask you is calculate the total distance covered by this object, or maybe by this car. Now, for us to find the total distance, we need to add the distance from A to B plus the distance from B to C plus the distance from C all the way to D. So that will be the total distance now covered. So I have got the distance from A to B as 7.5 meters plus the distance from B to C is just 15 plus the distance from C to D is just 5. So I need just to add the figures. Okay, so I have 7.5 plus 15 plus 5. Okay, so the answer I'm getting is 27. That will be the total distance now covered by this car. 27.5 meters. That is the total distance. Okay, if maybe they ask you to say the distance covered from B to D, then you need just to add the distance from B to C plus the distance from C to D. That is simple, guys. Okay,